How do I choose the right dimensionality reduction technique? Imagine trying to find your way through a crowded room filled with many people and objects. You need a way to see the most important parts clearly. That's what choosing a dimensionality reduction technique is like in machine learning. It helps simplify complex data so you can understand it better. But how do you pick the best method for your specific needs? Let's explore that together. First, think about the kind of data you have. If your data points follow straight lines or simple patterns, classical methods like principal component analysis are a good choice. Principal component analysis finds the directions where data varies the most, helping you reduce features while keeping the main information. If your data is labeled and you want to separate groups clearly, linear discriminant analysis might be better because it focuses on distinguishing different classes. Now, if your data has complex, curved, or tangled patterns, you'll want to look at nonlinear techniques. Methods like t-distributed stochastic neighbor embedding or uniform manifold approximation and projection are designed to keep local relationships intact. They are especially useful when visualizing data or finding clusters in high-dimensional spaces. Keep in mind, t-distributed stochastic neighbor embedding can be slow on large datasets, so UMAP offers a faster alternative that still keeps the structure well. Next, consider the size of your dataset and your computational resources. Principal component analysis is quick and scales well to large data. Autoencoders, which are neural networks, can handle very big and complicated data but need more time and tuning. If you want a method that balances speed and quality, UMAP is a good middle ground. Think about how easy it is to interpret the results. Principal component analysis gives you components that are combinations of original features, so you can sometimes understand what they mean. Nonlinear methods and autoencoders produce more abstract embeddings, which are harder to interpret but often capture more complex patterns. For example, in image generation or natural language processing, deep learning-based methods are often used because they handle high-dimensional data efficiently. You also need to consider how noisy or incomplete your data is. Some techniques like principal component analysis can be sensitive to outliers, while others like autoencoders are more robust. If your data has missing parts or lots of noise, choosing a method that can handle that will give you better results. Finally, think about the ethical side. Reducing dimensions can change how features are represented, which might influence fairness or bias in your models. Make sure the features you keep are fair and don't distort important information. In the end, selecting the right technique depends on your data type, whether you have labels, how big your data is, and what you need to do with it. For simple data or quick exploration, principal component analysis or UMAP might be enough. For more complex data and tasks like image or language processing, autoencoders or nonlinear methods are often the best fit. Always check how your choice impacts fairness and bias, especially in sensitive applications.